Welcome back to Inside Astronomy. January has been a strange month. Strange in that it actually looks like Christmas. About a week late, but nevertheless it's a joy to see the snow and to see the weather like this. It's been a while since I've had a cold, snowy January. But for the last few weeks, the dogs and I have been enjoying the snow, and of course the astronomy has taken a back seat to the weather. I think you can understand. It's one of the reasons that I haven't been able to put out a video in January so quick, but normal service I'm sure will resume, and this snow will of course melt, and that'll be the end of it for this year. The planets are bright, really bright. If you compare Jupiter currently to the brightest star in the northern hemisphere, which is Sirius, Sirius is magnitude minus 1.45, whereas Jupiter is magnitude minus 2.49. That means Jupiter is currently 3.6 times brighter than Sirius. This is the main reason that the planets take magnification very well. Finally, by the time you see this video, Jupiter will have passed opposition, which happened on the 10th of January. So it's more or less the biggest it will be in the night sky right now. So it's an ideal opportunity to image it. While you can successfully image Jupiter with a refractor, they're not ideally suited for this task, especially modern refractors. Modern refractors have focused on becoming faster and faster, and are therefore unable to achieve the high magnifications needed to image the planets, unless of course you have an older refractor or with a slower focal ratio. The telescopes that are used most successfully to image the planets are cassegrains, or Schmidt cassegrains pictured here. These telescopes have one fundamental flaw, and that is they focus with the primary mirror. For large DSOs this isn't a great problem, but for small things like planets, focusing with the mirror, any small amount of variation or mirror flop as they call it, will take the planet off the sensor. This can be very frustrating. Therefore, the common practice is to retrofit these telescopes with an external focuser and to lock down the primary mirror.
Scotty, beam us up! Scotty! Scotty!
Don't worry, Captain. It's only a shower.
I don't need a brolly, you wally! Beam us up!
Captain, I haven't got the power.
Try, man, try. Power! More power!
Man's power, man.
When it comes to the planets, you cannot have enough power, and by power I mean magnification. More power, please. Give me more power, Scotty. Come on. Get that warp reactor working. Now seriously, there's a rule of thumb, and this is why I say that refractors are not ideally suited for the task. The rule of thumb is you can get around about 30 times magnification per inch of aperture. Now, of course, some people are going to complain at that and say it's 50 or 60 times. And my answer or my response to that is quite simple. Yes, but that's for the more boutique telescopes from the high-end manufacturers. Your Takahashis, your Techs, or your APMs, whoever you want to list there. The planets need magnification, and the best way and easiest way to achieve that is with a telescope that already has a long focal length, such as a Schmidt cassegrain. An 8 to 10 inch Schmidt cassegrain is perfect for the job. Now you can add a Barlow to the system that can double, triple, or even extend the focal length up to 5 times the original. But if you're trying this with a refractor, you will notice that the image will degrade if you push the power too high. Finally, the recommendation here is to take the pixel size of your camera, and mine is 2.9, so let's call that 3, and multiply that by 5 or 6. That means that I should use a focal ratio of f15. In my case, I image with the Mewlon at f20. Many a flame war has started over this recommendation, so take it as that a recommendation that will get you into the ballpark and experiment from there yourself. I've been using this telescope, this Mewlon, for, well, almost a decade or more now. And one of the things I forget about, and I saw on a YouTube short where somebody was using just a simple Newton telescope to look at Jupiter, but just how impactful or how visceral an experience it is to actually look down the eyepiece and see a planet. But the other reason I wanted to bring you to this part of the telescope is to introduce you to this telescope superpower. The superpower of this telescope, to the probably the frustration of many a cassegrain owner out there, is the focusing of this telescope is done by the secondary, and it's done by a very small control box. So with this control box back here, I can now, through a cable that runs up to the secondary, control the focus of the Mewlon simply and easily. And because of the zone of focus of a telescope like this corrected Dalkirkham is so large, this is just a simple motor and just on, in, out on the control box, and you're able to bring Jupiter and its moons into focus. It's as simple as that. I know many people struggle and adapt their Smith cassegrains with other focusers, separate focusers, and lock the primary mirror down to stop the shift that they get when they focus. But this one, its superpower on the planets is it focuses using a secondary mirror. Very small adjustments and you get Jupiter in focus. So what I'll do now, I'll bring a mobile phone up and show you that process happening in real time. Not the best video in the world, but hopefully you can see what's happening. I couldn't quite align the phone with the eyepiece. Here we go, click in, and I move it actually out of focus. Click out, and now you can hopefully see it coming into focus, especially on the moons there. Finished. With the Mewlon, the Barlow in place, and the Neptune camera, I achieve around about 100 frames, about 96 to 100 frames a second, and I'm able to leverage lucky imaging, of course. I'll take anywhere from 10,000 to 20,000 frames depending on the night. And here is the final Jupiter. Lots of cables as usual. There is the player one, Neptune. Oops, let's get that in focus. Player one from Neptune. And then the sky.